So here's problem number 12 from the BC portion of the Bluebook practice exam. And this multiple choice question tells us that the integral of f of x from 2 to 5 has a value of 14. They ask us to use that result along with what's in this table that's provided to determine the value of this definite integral. So I look at this definite integral, clearly it involves a product. And one of the things you should be suspicious of in Calc BC anytime you're needing to do an integral involving a product is the need to use integration by parts. So in integration by parts, we start with an integral that is a product, two things, u and dv. Our job is to assign u and dv. Typically what we want to do is we want to let u be the thing that has a nicer form when we take its derivative. So of these two components, x and f prime, x has a much nicer derivative than f prime does. If I was to let u equal f prime, I don't have any information here about f double prime. So that's another reason why I think in this case it makes sense to let u equal x. And then that means dv is going to be the remaining portion of the integrand, including the dx. So when I take the derivative of u with respect to x, I get 1. And then if I solve that equation for du, I get that du is just equal to dx. Over here, if I do the antiderivative on both sides of this equation, the antiderivative of 1 dv is v, and the antiderivative of f prime with respect to x is back to f of x. So now if I apply the right-hand side of the formula for integration by parts, I need to express u times v, so that's x times f of x. That does have to get evaluated at the upper limit and the lower limit, and we have to take a difference. And then I need to subtract off the integral from 2 to 5 of v, which is f of x, du, which is dx. We have the value of this, right? They provided us with that number, that's 14. So all I need to do is I need to plug 5 in place of these x's, I need to plug 2 in place of these x's and take a difference. You see I've done that right here. I've got minus the value of that integral they provided us with. Got to do a little bit of arithmetic, and if you do it successfully, you should see that your answer is 13.